Hi. Oh, in the same room. Great.
Yes.
So
We have you on speaker and not headset, so I hope there's not any crosstalk.
oh no, it's working just fine.
Okay,
So thank you
perfect.
for joining us, Alexander and Sophie. As I mentioned, leading up to this, they've got a demo for their game that Alexander had a wonderful talk last year about procedural generation and assets, and now we have Sophie joining us for the art aspect of that. So without further ado, I'll let y'all take it away.
Yes, thank you. Yes, this is our talk, Hoist the Colors, Art Direction and Tech Art in Sea of Rifts, and it is a sequel to the talk I did last year. So in Sea of Rifts, you're the captain of a steam and sail ship, exploring a vast, dangerous ocean that's being torn apart by rifts into other dimensions. And it's your job to get to the center of the world. And we have done a lot of work on the procedural generation in the game. Mm-hmm. And yeah, we are quite excited to talk more in depth about how that actually works. We also have ship-to-ship combat in the game, and that adds a lot of challenges in terms of like how much art we have to do. And we also sorry, I'm a bit nervous. We are also very reliant on procedural generation across the game. So what you see here is a harbor that is using like generation. We generate the harbors, we generate the quest lines, and we generate the crew members that you can hire. So it's a very roguelike game. And yeah, this is us. My name is Alex. I'm the creative lead and designer and coder on the game.
Mm-hmm. And hello, my name is Sophie, and I am the art lead on Sea of Rifts and have been so for the past 2 years.
Yes. And the agenda for the talk is that I'm first going to cover some overall goals for the art direction in the game.
And then we're going to go and dive into the art direction. I'm going to show you some of the decisions we made along the process and talk a little bit about some of the techniques we applied throughout.
And finally, I'm going to do a deep dive into some of the tech art we used to achieve that direction.
Mm-hmm. Yes, but first of all, let's go and talk about the goals for this production. So Sea of Rift is a very large game, and we're a very small team. And so one of the major goals for the visual direction of Sea of Rift has been to how we can create the most visual variation with the fewest assets possible. And because we figured out that we have this top-down perspective of the game, which caters really well to the stylized art that we decided to go for. And a good thing about the stylized low-poly art that we went for is also that it's speedy to produce as well. So, and it allows us to create a lot of variation swiftly with just applying new textures on top of very low fidelity art. Some of our major inspiration for the visual direction of the game are the Anno series and Kenshi, as well as Dota.
Yes. So when it came to how we should work on the game, I had 3 principles that I wanted to make sure that we followed. The first was that I, as the tech department, didn't become an implementation bottleneck. So everyone on the team should actually be able to push content into the game. And secondly, that me as the game director did not become a decision bottleneck. I really hate micromanagement, both being the one that has to do it and the one that is on the receiving end of it. So it's been very important to me that everyone had the agency on the team to put stuff in, not necessarily without checking with me first if it was okay. And that also hits on the third one, which is iteration. How quickly can we actually work on the game? Because if you can't iterate on a game, you are in for a world of pain. And one of the books that's inspired me quite a lot when it comes to how I think about this is Turn the Ship Around. Very fittingly, it's written by a naval captain that took the worst performing US submarine and in a year made it the best performing one. And that was basically by letting go and letting people get get to that and do their job. I also think it's important to have a balanced approach between how efficient it is to work on your game, so your workflow efficiency, but also how long does it actually take you to implement those tools, because me as the only technical person on the team, I'm a rare commodity, and then also the end result needs to be performant enough that people can actually play the game. So how do we do this? Well, one thing we make sure of is that the game is always playable. So we have automated tests we can run, and we also have a very flexible workflow for trying out things inside the engine. We also try to have a very shared ownership of the game. So like the usual thing that happens is that the artists, they focus on the aesthetics and the visual niceties of the game. And the programmers, we're looking at the numbers and we're like, oh, the frame rate is terrible. Oh, what should we do? And the best game happens when everyone shares responsibility for like all of those areas. And I think it helps a lot that we are very flexible team. I like to say that we are a team of octopuses, and yes. we have a lot of like shared skill sets, so we can like come in and actually like offload each other, which is super nice. And also we do a lot of play tests, because that's what keeps us in check. If something has been tested and for example the frame rate is bad, we will know and we'll have to do something about it.
All right, so now we'll go in and cover a little bit about the art direction, some of the decisions we made throughout the process, and some of the techniques we applied to like really make our production as efficient as possible with the resources we had. So when I started this project like in 2023, I was the only artist, and that was like, okay, this is a little scary. This is a big project. So what do I do? Well, first of all, I tried to figure out, okay, so where can we cut some corners without making it too obvious in the art style of the game? Like, well, how can we maximize the potential of the assets we produce and make sure that we use them in many places of the game, but maybe create variation through texture swap and different types of colors, as well as also making sure that, as Alex just pointed out, that he doesn't become a bottleneck and nobody else becomes a bottleneck in the production, that we have to free up the dependencies on the team, ensuring that the artists can actually are allowed to like finish their tasks without having a middleman coming in and improving on the side. So one thing that when I started this project was to look at how we could make a good way of running the process of this, the art direction of this game. Being such a big game, it's quite a mouthful to steer. And one of the tools I would use throughout the process has been Miro for actually establishing this art direction board. Miro, we give a general overview of the art of the Sea of Rifts. We present some of the inspiration it draws from, some of the resources we use throughout the process. And because we have so many different environments in the game, so many different types of ships and so forth, initially I wanted to use Miro also for making these detailed style guides for the game. But I realized in the process that actually using Google Sites was the best option. So that's the next thing. Like we use actually just Google Slides for running these detailed in-depth style guides for instance, covering the environment of Sunken City. And it's a very nice tool just using slides because it's easy to modify, it's easy to share, you can print it and whatnot. Everyone has easy access to it without having to create a lot of accounts. And in general, I have this rule of thumb saying that you should avoid juggling with too many tools. Like there might be a lot of smart tools out there, but the tools aren't smart if you're not using them and if they just cause a lot of friction in the production and actually stall the production of what you're making, then you might as well just get rid of it and stick with a Google Sheet document. So Sea of Rifts is, as we said, a very content-rich game. We have several ship types. We have a lot of different factions. And we decided we have this top-down camera, which caters well to this low-poly stylus style that we went for the 3D assets of the game. And But one thing we had to think about throughout the process was how can we establish a visual hierarchy for this game, because the players need to be able to decode which factions do the ships belong to, and what types of ships are there. So, and there are different ways for you to establish a visual hierarchy in a game. Especially for top down, you pay a lot of attention to the top parts of the elements. That's what you spot first. So one thing that we really are mindful about as artists is making sure that we distribute the values across the elements in the game in a way that creates enhanced depth perception, but also make sure that we point interest to the most important aspects of the assets in the game. So as you can see here on this slide with some of the buildings from Sunken City and the Sheepfolk settlement, notice how it's darker at the bottom and actually gets brighter at the top. And also at the top that we have all the details of the building primarily situated there. Another thing that we also work a lot with is contrast in colors and shapes. The human eye has does instinctively look for boundaries between areas that has a lot of contrast. So as you see here for the Sheepfolk boat, this long boat, there's a lot of contrast in the coloration of how the spikes and the rooftop, making sure that we tell the players, "Oh, you should not touch this, it's gonna hurt you." And also the enemies, as you see on the right, they are very, very bright purple, making sure that they stick out from the ocean, but also making sure that the weaponry is very nicely contrasted to the surroundings. And talking about contrast, I can't help but talk about that. Okay, because we see things very often from afar in the game, we have to make ways for making sure that everything is readable at all times, no matter how close you get with the camera. And one way we do that is to really accentuate sizes and shapes of objects that are important. So for instance, the ramming weapons, like this blunt bone weapon here, it does not look proportionally realistic, but for a stylized game and for the sake of readability, making sure that the players can see the weapon from afar, this is quite important. This is a way for us to make sure that people can always tell what's going on the screen, wherever they are, and wherever the camera is. And obviously, throughout this process, we've been looking at a lot of different type of references, right? And I couldn't help but think of my childhood favorite game was Sid Meier's Pirates, which I think did a really good job at creating these contrasts. Just notice how the city of San Juan here in Pirates, it's really standing out. The rooftops are really bright red. It's sitting in a very green area. The ship itself is very nicely contrasted to the ocean, making sure that we can easily decode and decipher the shapes and what's going on the screen. And so does games like the Settlers, where you can easily tell from the shapes and the coloration when you look from top down what these functions of these buildings are and who they belong to. And in case anybody's interested in looking up how you can create assets for a top-down game, I can really recommend this character art guide from Dota 2's workshop. It's really nice. It gives you a nice overview and analysis of how you can produce assets that are easily readable in a top-down perspective. Another thing that we have been working on, especially for the past year, is how we can add depth to our game. So most of the game is covered by ocean, right, Alex? It's 80% of the time when you're out at sea, there's so much ocean. So okay, we have this ground for storytelling, and how can we actually use this water for establishing some storytelling, to plan cues for past events that have happened, but also to plan cues for all the creatures that loom beneath the surface. And this is a way that we have this kind of hierarchy where we have the underwater assets that you sail above and can explore. And this is also a way for us to spark the curiosity in players to go out and explore this world. Okay, so But how do we apply all of these rules? So for the very production of the assets in the game, we apply this we have this modular design approach, both for the ships and the buildings. And what do I mean by modular? So remember when you were a kid and you had these toy blocks that you could build castles with, and the cannons and unicorns and whatnot. You might not have had a lot of different variants of blocks, but it didn't stop you from using your imagination and to actually create more of it than what you actually had. And it's kind of the same thinking process that we're trying to nurture in Sea of Rifts, is to maximize the potential of our assets and create every 3D model as a module that can be built, like, so we can assemble ships and buildings like Lego and build ships on the fly in the engine, which has been a huge success because it means that everybody on the team can go in and build a ship when they need one. And as you can see here, just as an example, we have maybe 3 types of roofs for the ships, and we use them for 10 different types of 10 different types of ships. So it's like we can really maximize and reuse assets for a lot of things. Then another way for us to make sure that we have proper color variation in the game is that we have, like, Alex has made this HSV offset shader in collaboration with me, which makes sure that although we only have 3 different types of texture atlases as presented on the slide for all the ships, we have this database, this shader, that makes sure that we can do color swaps and actually have a whole range of different colored ships, which is really good, especially for when we want to make sure to convey that this ship belongs to this faction and this ship belongs to that faction. Of course, it's, as it always is, when you're a small team, you have to also look at, okay, so I was talking about how to cut corners. And sometimes one of the best ways to do that is to use store-bought assets, right? It can be a good way to test things that are like still work in progress. It can be a good thing to do to speed up production. And you can actually achieve a lot if you just reskin your assets. Then it can look like it actually always belonged to the game. The con of using store-bought assets, though, is that you don't have any production files to backtrack to, and you also have a risk of that your game loses character, meaning that it becomes like, it kind of ends up looking like a series of stock photos. So be wary with how you use store-bought assets. Okay, so the cherry on the top. So one thing we really utilize is post-processing in Unity. It works really well. It's a very good way to make sure that everything you see on screen comes together nicely. And because we have so many different environments, this is a way for us where we use vignette and lighting to really make sure that everything in Sea of Rifts, it just works together. No matter if it's store-bought assets that's combined with whatever we ourselves produced, right? So this is something that we've really been happy to use as well. It's very efficient and can only recommend using it. All right, so let's go and talk about the tech.
Yes, let's talk about some shaders.
Yeah.
So a trick I talked about last year was how we use shaders to add visual variety. And I think I could do a better job of showcasing how that actually works. So for example, here for... see, I think we have, okay, there we go. So we have a streaming world setup, which means that the only constant data we have for each game object that is looking static to the player is actually the height and the angle. But that is still enough that we can actually derive a random like value from that. And we then use that to apply a random color offset to the model. And it's very fake. Like normally you wouldn't have like that a whole house in a city is like a little bit darker than the house next to it, but because the houses are so small on screen, it's not actually something that you really notice. You just notice that there is some variation to them, and that variation is actually adding quite a lot. So for example, here we have it with the variation, and here we have without, and you can see it's a lot more flat and dull to look at, whereas like here you get that like there's like just something with like having enough natural like noise in an image that is appealing to us to view. And also we can use the same noise value to change how much light that there is in each house, and that also adds life and character. So we use a similar trick for algae on rocks. So this is actually the same rock 5 times, just rotated differently, and then that rotation and random height is used to dictate where the algae is actually being placed on the rock, and it adds a huge amount of variation to not a lot of assets.
Yes, it really does.
This is how it's done. We basically just grab some data from the model view matrix and the world matrix, and from that we calculate some dot products and do an fmod, and that's it. It's not really like super complicated. If you're doing a game where you're not moving everything around on the XZ axis because you're streaming it, you can just probably take the object's world position and rotation and go nuts. But yeah, we had to do this little bit of workaround. One drawback there is from having this very kit-based approach to assets is that if you don't do some kind of optimization, you end up with having a lot of game objects, a lot of draw calls, and a lot of unhappy players because the frame rate is on the floor.
Yes.
So what we do there is we use a plugin called MeshKit. There's a lot of other plugins out there that can combine multiple game objects and their mesh renderers into one larger object. And here it actually is really nice that we have a few atlases for each ship family, because it means that all of those meshes can then be combined together and use the same texture. So one thing that was really interesting for Sunken City, which is by far the most complex biome we've done in the game so far, is that we needed a lot of verticality to the structures, and I was basically like, okay, I don't want to become a bottleneck. So what I did is I made this quite simple generator, really, that just stacks elements on top of each other. And there's like different stacking rules. So like it can either repeat 1, 2, 3, or add them at random. And then I basically let the artist go nuts with
of stacking modules to create different types of buildings. So while Alex was working on this, I was drawing out concepts for, okay, so how much visual variation could you actually get from just a square, so to speak. And I handed over this concept to our artist Birke, and then he just did some magic in Blender, creating these modules and export them out. And then, yeah, you have it. We got these buildings, as you see here, an example on the right, these nice buildings for Sunken City, using this method of stacking and stacking different modules to create more different types of buildings.
And what was quite interesting is that as soon as you give a tool to someone else, they find ways to, I could say abuse, but let's say using creative ways. So for example, the building here on the right, Birke, he actually found out that he could add pillars to the top section of a building and then just like extend them way down, and then like all of that version of the building with that roof would have those corner pillars, which is like a really clever use of the generator.
Yeah.
So another thing that's I'm also really pleased I finally got to use in a game that people have actually tried is what I call the subtiling system. And it is trim sheets combined with 9-slice sprites. And to go over what these are quickly, trim sheets is basically that you can use the fact that textures can tile in either the width or the height, or both. And 9-slice sprites is that you take an image and you slice it into 9 pieces, and then you can basically use that to create corners that don't stretch while you can stretch the sides. And I've come up with a way of combining the two. So when we are texturing these buildings for Sunken City, we actually have this large tile set you see here on the right. And then for each vertex, we define the position and UV as normal. But then we also define an offset to that tile we want to show, and we also define the tile dimensions in the vertex data. And that actually allows the shader to basically take the current UV, offset it, and then repeat it with the frequency of the tile dimension. And that way we can actually show a lot of different textures from one texture. And we're not bound to the limitations that there is with a traditional trim sheet where you have to like basically stretch it to the edge. And what was really interesting to me is I made this technique for a game where I was actually generating the buildings by code. But when Beato got hold of this, he was like, well, I don't need to stick to your rules. So he
rule breaker.
So he started like using like odd offsets and actually like odd tiling dimensions. And what you see here on the left, that's actually where he's used that to create two different window types with the stained glass, even though there's only like one he's picking from. So it's like a really interesting like way that he found a way to get enhanced use out of it. One thing that you might run into if you use this technique is that as you go down your MIP levels, you will start to get like bleed from tiles into each other. And the way to get around that is that you have to pad each tile and basically like make that repeat onto itself. And this was quite a hassle to figure out back in the day. Thankfully, we haven't really had to deal much with it on Sea of Rifts because of the camera, but it's something to be aware of. And it's something that you can script your way out of in Unity, for example, with a custom texture importer. All right, paper.
Oh yes, paper, Alex.
Yeah.
Wow, we have so much paper in the game, you know that?
Yeah.
And in the beginning, I was drawing paper, and I was drawing paper, and I was drawing paper for so many kind of use cases. Because we have a very dynamic content in the game where we use a lot of different types of sizes of paper for the UI. I drew a lot of paper sprites. But this was, as you kind of can imagine, in the long run, this was not the most efficient way. So, Alex, I just want to ask you, could we do this with a shader?
I mean, yes, we can.
Yes.
Yes, we can. So the first thing is, can we get the surface of the paper? Yes, that is actually quite easy. We just take the screen space position, we use it as a UV, and then we apply a paper texture. It looks like paper, but it looks like a very modern paper because the edge is very clean. This looks like it's just been bought at a shop. So how do we go about fixing that? Well, we use what is, I think it's going to become my signature technique because I also talked about using it for land generation last year, and that is used assigned distance field. So assigned distance field is like magic. It is super easy to use, and it scales well to a lot of different like it basically like lets you take in discrete input and kind of turn it like into something that looks more organic. So the whole secret is that it's in this case it's a grayscale texture with a bit of noise where we are accentuating the corners and a bit of the sides. And what we then do is that assigned distance field is actually quite easy to understand. It is just that you pick a threshold value and you say I am inside if I'm above the value and or below, and the other way around for the other case. So that's, and if you can then like set that value dynamically, then you can like basically set like exactly where you want the shape to appear. And if you combine that with that paper texture we had before, you start to get something that actually has that like that pirate map look with the frayed edges. What's also really smart is that if you then 9-slice that assigned distance field map, then in Unity, when you're resizing your UI elements, the paper will just automatically get like to look still with like that edge. One problem that there is with this technique is that if you're using the same SDF across your whole game, and you probably will, then it can become quite clear that it's the same shape getting repeated, and that's because it's the same noise like the same field that's actually being displayed underneath. The way to fix that is by adding noise to it. And again, we can just do that in screen space, like we did with the noise we're using to create the paper texture. And you can see here that is actually a really good way of modifying the shape of the paper. A little trick that I think I also got around to implementing is that we can take the individual vertex color that can be set in the Unity's UI system, and then also use that to create a bit of an offset. So that creates even more variety.
Right, and we're running close on time.
Okay,
so you know.
All right. It can also be used for shadows. Also, there was a talk about the dreaded oatmeal problem. One thing that we ran into is that a lot of our islands look the same. And the way that I fixed that, you're going to get a little tip on that here. That was basically by having all our props be defined in a range that they could appear in. And then each of these prop set would also like define a weighting for each of the props. Then we have a weighting, or like a weight range for each of the props. And each harbor then picks a range that they pick from. And from that, you then get islands that actually look different, even though it's the same amount of props, or like the same prop set that has been pulled from. And yes, summary. So it's really important that you let everyone on the team contribute to the generation in your proc game. They will surprise you with the creativity that they can bring to the table.
Yeah, and make sure that there's a very strong collaboration. Like we just came up with some examples of how the magic can happen when we start like tossing ideas at each other with like the building generations for the Sunken City, for instance. Yeah, and also figure out where you can cheat. Like where can you cut corners without losing too much of the visual quality? Because we have a game where the camera is far away, it's okay that there's not enough of high fidelity or a lot of details in the game, so to speak.
Yeah. And lastly, shaders can add a lot of variety to a small selection of props, and I think it's one of the areas where there's still a lot of room for exploration in procedural games.
Yes.